How can I write and apply explicit formulas for geometric sequences? Remember arithmetic sequences where you took a sub n, you could find the nth term if you did a sub 1, the first term, plus the common difference times n minus 1, whatever term you're doing. Remember that? So this is dealing with sequences again. Geometric sequences, however, are exponential functions because they grow by equal factors over equal intervals. That's a key thing to remember, that you're multiplying now instead of adding. So it grows really, really fast. And you'll see that in these examples here. So here's an example. It goes 1, 6, 36, 216. See how quickly it goes from 1 up to 216? So if we said 1 is our first term, or a sub 1, the second term is, what are we multiplying by? 1 times 6. So 1 times 6 is a sub 2. A sub 3 is then 1 times 6 times 6. 6 times 6 is 36 times 1, right? And then a sub 4 would be 1 times 6 times 6 times 6. So what you could do with this is you could really think about it as you could even say this is 1 times 6 to the 0. And you could say this is 1 times 6 to the first. And this is 1 times 6 squared. And this one is 1 times 6 to the third, right? So you can see, and if you look at my exponents, it goes 0, 1, 2, 3. And this is a sub 1, a sub 2, a sub 3, a sub 4. You could actually rewrite this as n minus 1, similar to how we had that whatever term it is, minus 1. And this 6 here is what we refer to as the R value, or what we call the common ratio. Let me kind of write that out here. Common ratio. And the common ratio in this case is 6. So we do a sub 1, which is going to be 1, times 6 to the n minus 1 power. Or you could say a sub 1 times r to the n minus 1. And that's the more generic way to write a geometric sequence. Let's get into another example here to really work through this. I'm going to change to a marker that maybe will show up a little bit better. Let's go with green. All right. So in this case, you have a more complicated one because you're multiplying by a negative. And you can see it goes positive, negative, positive, negative. So 5 times negative 4 equals negative 20. Negative 20 times negative 4 is going to give us positive 80 because the negatives cancel out. And again, 80 times negative 4 goes to negative 320. So in this case, our a sub 1, our first term, is going to be 5. So if we were to say a sub n, whatever term it is, equals a sub 1 times r to the n minus 1, we could say that a sub n is going to equal 5 times r, which in this case is going to be negative 4, to the n minus 1. You could say a sub n. And that would be our equation we could write for the geometric sequence. We take the common ratio of negative 4 that's being multiplied each time, start with our first term, and just multiply through. And that's how you would write this as a function. And what we can do is we can actually figure out the 7th term. You would plug this into a calculator. I'm not asking you to multiply this because this number gets pretty big pretty quickly, especially when you're doing 4 to the n. So we do n minus 1, you get 6. You do negative 4 to the 6th power, and then you multiply that by 5. You end up with 20,480, which is a positive number. So it ends up being positive for this case, but that would be your 7th term, plugging 7 in for n into this equation. And that is how we can write and apply explicit formulas for geometric sequences.